Good morning, my name is Romain DUBALLET. I work at XtreeE, and today we'll talk to you about three main projects that have relation to what we call offsite 3D concrete printing. XtreeE is a company that's been founded 6 years ago, and we are doing large-scale 3D printing of various material from concrete to plaster, geopolymers, and earth-based material. We have developed a technology that we equip our client with all over the world. It's based on a bi-component technique when we add admixture to material in a printing head to make it buildable. This allows us to do what we call oriented lace pressing when we press laces onto each other and we control their shape by rheological properties. The main interest of this approach is geometrical freedom, and we use these techniques to do off-site robotic manufacturing, allowing us to have a better quality and timing control and to do performance-driven design when we can include different constraints for the building elements from thermal or mechanical performance to handling, for example. The first project I will present you today is a furniture series that we have developed with a French distributor called Roche-Beaubois. It's been designed by Fritsch and Durizotti, and it's inspired by coral reefs. The table is actually customizable. On Roche-Beaubois website that you can see an image of on the left, the client can customize its own table and choose the shape, number of lobes, and texture. Once the order is confirmed, we receive directly the printing file in our factories and we manufacture it. Then the table is assembled with the glass and the bottom part, and it's sold. This project is very interesting because we have created a digital continuity of mass customization for furniture. That was one of the promise of 3D printing. At a larger scale, another project that we are currently building are 5 houses in Reims, in France. Those prefab houses include 3D printing walls that have been certified by the CSTB, a French regulation authorities, and the walls have got an avis technique expérimental, allowing them to perform as separating walls to withstand some shear and to ensure watertightness for the house. Those masonry walls are prefabricated thanks to off-site robotic manufacturing. In fact, the whole house is based on off-site manufacturing. The 3 main elements, the printed walls, the CLT roofing, and the bathroom and kitchen made in metallic plus timber, are all prefabricated off-site to reduce the operation on-site, meaning that we reduce timing and uncertainty on the construction. On those pictures, you can see the first prototypes of the wall that has been assembled together on site in Reims. And the last and largest project that I will mention today is a 45-meter footbridge that we are designing for 2004 in Paris. It's been designed by Lavigne Chéron Architects and it spans over a canal in Aubervilliers. The main part of this bridge will be entirely 3D printed concrete without casting, and it's going to be post-tensioned. This structural concept is very interesting to reduce material quantities. But we asked ourselves recently, what about the environmental impact? So we have conducted a little study to try and compare 3 post-tensioned concrete bridge together in terms of life cycle analysis. You can see on the picture there that we compare our printed bridge. We don't see exactly how it's done inside for now. And we compare that to a traditional post-tension concrete bridge and a fibered high-performance concrete bridge. We have made everything at the same performance, same span, same forces, and we try and compared a priori the environmental impact in terms of life cycle analysis. This has been made possible thanks to the work of Katerina Kuzmenko that has qualified the environmental impact of 3D concrete printing, including the energy consumed by the robot. So you can see here the result on climate change, and we drastically reduce the impact with our solution, which is solution A. Solution B is a high-performance fibered concrete, and solution C is the traditional bridge. The traditional bridge is more impactful because we have more material, and our solution is lighter. Solution B is more impactful because despite being light, the concrete itself is actually highly impactful, especially due to the fiber reinforcement. In our case, we have very light and we are doing total post-tensioning. In addition, we have added some aggregates to our printing, reducing its impact again. This is the end of the presentation. I thank you very much for your attention, and I'm looking forward to discuss with you. Thank you very much.